Next is the D block elements. D block elements. These are called transition elements. They show variable oxidation states. They show coloration as well as magnetic property. They are widely used in making catalyst like, for example, like nickel, platinum, palladium, osmium, etc. They are present from group 3rd to group 12 of the periodic table. 12 of the periodic table. 3rd to group 12 of the periodic table. Right. And the general outer electronic configuration is, first to write the inert gas N-1 D1 say 10 and NS0 to 2. It is what? It is NS0 to 2. Everywhere it is NS2 to 2, but in exceptional case you can apply either 0 or 1 or N-1. N is the number of period and the D is the subshell, and D की capacity 1, 2, 3 up to 10. So again you remember this formula. This is very important. Outer electronic configuration of transition element is inert gas N-1 D1 to 10 NS0 to 2. That the way you can have the electronic configuration. Like say if N is equal to 4, then you apply, for example, scandium 21, right? So which is the inert gas you can use here? Argon, because of 21 is close to argon, and it is a member of 4th period in the periodic table. Which element? Scandium. So 4 minus 1, 3D, and again it is 4S, because here 4 minus 1, 3D, and here 4S. So it is the D capacity starting from 1 or S2, 2 plus 1, 3. So it is the member of 3rd group of the periodic table and 4th periods. Like for example titanium 22. Again you write the argon 3D2 and 4S2. You write the vanadium 23. It is the argon 3D3 and 4S2. In case of vanadium you write here chromium 24, argon 3D5 exceptional case and 4S1. Because of chromium is an exceptional case, so you write here 5. Manganese 25, argon 3D6 4S2, sorry 3D5 4S2, iron 26 3D6 4S2, and then iron. Then you write here cobalt 27, argon 3D7 4S2, nickel 28, argon 3D8 4S2, copper is exceptional case, argon 3d10 and 4s1, and zinc. These all elements are from the fourth period of the periodic table, 3d10 or 4s2. So I would like to explain why I have written 3d, 3d and 3d, because all are the member of the fourth periods. Period means LHS to RHS. All are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. 21 say 30 member of the fourth period. So 21 scandium, atomic number 21, it is close to the inert gas argon. 4 minus 1 3d and decay capacity 1, 2, 3, 4, 5 up to 10 NS 0 to 2. In between, if there is any exceptional case, then you write like chromium and copper, that is the 1 and 1. So I would like to show the position of d block elements in the periodic table. So here we'll remember it like d block elements are called transition because of they have incomplete field d orbitals and they show iron, for example, ferrous and ferric, copper, cuprous and cupric, like they show variable oxidation state. Position. First of all, you write scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. This is the 3, 4th, 5th, 7, 8, 9, 10, 11, scandium, yttrium, lanthanum and actinium, zirconium and hafnium, niobium and tantalum, molybdenum and tungsten, Tc and Re, Ru, Rh, palladium, osmium, iridium and platinum, copper, Ag and Au, zinc, cadmium and mercury. Dear students, here that you classify as per the vertical columns, right? And I am going to ask you the group number, right? In that way, just to think before it. These are the member of 4th period, 5th, 6th and 7th period. Here is the third, scandium 21, 22, 23, 24, 25, 26, 27, nickel 28, copper 29 and 30, mercury 80, cadmium 80 and 48 and mercury 80. Now 39, 40, niobium 42, 43, 44, 45, 46 and 47, 57, and there you make the star here because of lanthanide series takes place. Then 58 to 71 is the lanthanide series. Lanthanide series, that is the F block, and 72, 73, 74, 75, osmium 76, iridium 77, platinum 78 and gold 79 and all that, and actinium 89. So 92, 103, thorium to lawrencium 103 and cerium to lutetium are the member of F block elements. This is known as actinide series F block elements. So 104, 105, 106, 7, 8, 9, 10, 11, and what is that? 12. So what is the IPAC nomenclature? Unyl quadium, unyl pentium, unyl hexium, unyl septium, unyl octium, unyl anium, unnylium, ununium, unbium. So the way they are the position of the, you can see D block elements in the periodic table, right? So these are the lanthanide series and actinide series. If you want to change, if you want to explain the position of the iron, for example, so iron is what actual atomic number of iron? 26. It is the argon, 3d6 and 4s2. 6 plus 2, 8 group. Iron is the member of 8 group, 4th period and D block. The way you can have. And the last is the F block elements. Only you know the general information about the F block and outer electronic configuration formula. So dear students, F block elements, they are called as inner transition elements. They also show color and magnetic behavior. Their outer electronic configuration is inert gas N-2 F1 say 14 N-1 these 0 to 1 or NS2. It is the ultimate cell. Ultimate cell. It is called as penultimate cell, and it is called as anti-penultimate cell. Ultimate cell, penultimate cell, and anti-penultimate cell. So N is here period. N is the period. N-2 F1 to 14 N-1 T0 to 1. Right. So N starts from 6th period as well as what period? 7th period. 6th period is the lanthanide series. That is the 6 minus the xenon is here. You can write here xenon. 6 minus 2 4F. 6 minus 1 5D and 6S. This is the formula of the lanthanide series. So far as actinide series is concerned, it is the radon 86, 7 minus 2 5F, 6D and 7S. The way it is the lanthanide series. Lanthanide series, and it is what series? Actinide series. The way you can write the position of F block elements are like, for example, in case of the lanthanide series, I can write here period 6th lanthanide, lanthanoids. La is no doubt D block, but property is very close. That is why I have written here PR, ND, PM, SM, EU, GD, TB, DY, HO, ER, TM, YB and lutetium. 71, 58, 59, 60, 61, 62, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70 and 71. These are the member of lengthenoids. Now come for the member of actinoids. 89, then you write 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102 and 103. Lawrencium, thorium, Pa, uranium, neptunium, plutonium, Am, Cm, Bk, Cf, Es, Fm, Md, No, Lr. So dear students, I have classified all the blocks: S block, P block, D block and F block. F block elements are called inner transition elements, and they include lanthanide series as well as actinide series. 14 plus 14. Total F block elements are 28 and all of them are metals, including radioactive as well as non-radioactive elements. So you have to remember atomic number, at least name of the elements, so that it will be helpful in your 12th class, right? So you have to go through all the blocks: S block, P block, D block and F block, and the way you have to retain and remember the atomic number, position, block, and more importantly general outer electronic configuration formula. Thank you very much. Have a nice day to all of you.